Alright guys, here we go with another episode of Tech Time with Ben. Today I have a stepper motor from an old scanner that I have. It's right now I have the code just running it to step through one direction and then step through the other direction, just to, I don't know, show basic functionality really. I don't really have any plans for it yet. Although I do have the belt that goes onto this pulley, but basically what I did is I have the original the entire board from the scanner, and I modified the power so I could use a computer power supply, because I don't have the original power supply for it. And on the back you'll see that it has a it actually uses a Darlington array, and you can see where I patched in my four control wires for it. And then I just have a huge mass of thing of hot glue just to keep it so that I don't break the delicate traces there. Then I have it going over to the Arduino. And it's pretty simple. All it uses is just the four wires. And in this case I have it attached to 8, 9, 10, and no. 9, 10, 11, and 12 pins on the Arduino. And then I have that, of course, connected to the computer for power. The code's pretty simple. Just uses the stepper motor library, and I will go over the code a little bit here in a little bit. But, pretty simple. It was kind of difficult to get, let's see if I can zoom in nice here, to get these, gosh that's shaky, it was kind of difficult to get these soldered on there, just because of the pitch, as in other words, the how close together each thing is. So here's my fingernail for comparison. That's a pretty fine pitch, but if you have a steady hand and patience, you can get it done pretty easy. So so here I'm going to go over the code for the Arduino that I have, for the stepper motor. So basically, the first thing that is here in the code is the include stepper.h, which all this bit of code does is call up, well, first of all, it calls up this file, which is a library file, which obviously the comment right here says that it includes stepper library. But then we have to tell it which pins we're using, and so since I'm using a stepper motor that has 4 wires, I have 4 pins, and so I have 9 through 12 pins, 9 through 12, and so we're initializing in 1 pin, in 2 pin, in 3 pin, and in 4 pin, and the relative pins. Excuse me. So now we're going to call up the stepper class by doing stepper motor, and then in the parentheses you say which pins are what, or how many pins, which tells the class basically how to drive it, because whether or not it's 4 pins or 2 pins. Since we have 4 pins, we include all 4 pins, and then this right here is the number of steps of the motor. So what that means is how many steps or pulses does it need to make one full revolution. And with my motor that I have here, I believe it's about 50. It seems to be pretty dead on for 50. So that's what that number is right there. Then you go into your setup, and so right now, set motor.setSpeed. What this does is it sets the speed of the motor in RPMs. And so right now I have it set at 400, which is about the most I can get without it stalling when any sort of pressure or resistance is applied to it. because the faster you drive these, the easier they are to stall. They don't have as much torque. And then you have to set up the pin modes, and so you go tell it that's the pin here that we just set up, and the mode for it is going to be output. No, that's going to be for all four. And then we go down to the loop, and here we have motor step, and we're telling it to go 8,000 steps, and then once it completes that, it's going to delay for 1,000, I believe, milliseconds, and then it's going to go step 8,000 in the opposite direction, and how it determines for it to be opposite is it's negative. So I looked in the the C file for the stepper, and it has a bit of code that says if it's greater than 0, if the step is greater than 0, then drive the pins in this order. If it's less than 0, then drive it in this order. And so that's how they're able to get the direction is driving each pin in which order they drive the pins. And of course, delay of 1,000, delay of 1,000. So this part here will continuously loop until the power is interrupted, or you have something else, some other bit of code that waits for an interruption for it to interrupt. But otherwise, this will just sit here and go through this part indefinitely. So that's that bit of code. The code that I started off with is actually this bit of code here, and it's pretty much the same. It's just this is actually from the Adafruit Arduino lesson 16 for the stepper motor. I just copied pasted it and edited a couple of the fields. I was messing around with seeing if how well the motor performed with different steps for revolutions, and 24 or 25 it basically rotates half because it's 50 steps per revolution. Void setup, same thing. All the pins are the same. But what this bit of code does is you can actually go in and open up a serial monitor and type in how many steps you want it to do. So like if you want it to go one step forward, you type in 1 and it'll step 1 once. Or if you want it to go 1 revolution, in this case, in my case, I'd type in 50 and it would turn 1 revolution. And the way it does that is, so while serial, this is just kind of like a wait for it. So to make sure that for the Leonardo, I guess it delays it until the serial is open. And then when you open the serial, it wants to do it at 9600 baud. And then of course the motor set speed is this one set at 25. And then we go into our loop. So it's an if-then statement, and basically all we have is just an if statement where it says if serial.available. So basically if serial is available, then goes underneath here, it says init steps equals serial and parse int. So basically what this says is whatever number comes in from serial, which would go right in here, then it would translate to how many steps, and then it would say so this right here references this bit here, which says okay, so I'll put in 20 steps, and so it would put in 20 right here, and then it would move 20 steps, and then it would stop, and then it would wait for another step command, basically. So all in all, it's actually really simple code, really easy to get up and running.